Hey guys, so I've got another project to show you. This is another Arduino project and it's kind of a simple one, but it's something I've been meaning to do for a while. It's a temperature sensor, a logger, a data logger I guess. At the moment I'm using the Ethernet shield because it's got a built-in SD card and it means I can record to that from there. And it's using a small temperature sensor. I can't remember what it's called. I'll put the name of it just here somewhere. But it has 3 wires and shove power into it and get data out. It's quite simple. There are lots of example sketches about for this, but I wanted to sort of combine a few of them so that it was a data logger and it displayed on an LCD display as well. It's been running for about 5 days now, so it's collected a lot of data, and I knew it was cold in my flat, but I didn't know it was quite as cold as it did get. It's nice and warm in here today because I've put the heating on. Let me show you here. So this is it. I'll give you a closer look in a second. It's just an Arduino, an Ethernet shield, a temperature sensor and an LCD display. It's just a 16:2 LCD display. Now it's been quite complicated because the Ethernet shield uses a bunch of pins, and the standard sketch for the LCD display wants to use the same pins, and so I can't let it do that. So I've had to resort to using some of the analog pins, and you can use those by referring to them as pin 14 to, what is it, 18, 19? I can't remember. I've only used 3 of them, I think. And so let's get a close look at this, and then I'll show you what data it's kicked out, and I'll also put up the code. Alright, so here it is. It's pretty simple. It's just the Ethernet shield there with the little SD card down here. If I can get it to focus, there we go. LCD display, currently 18.69, and here is my temperature sensor. It's in a waterproof packaging, and these are the wires coming down here. Now it's very, very simple to wire up. It's not, it can do it straight from a breadboard. There's a few resistors in there. There's one for the LCD display to set the contrast, and there's one for the temperature sensor, so it's sort of like a voltage divider, I guess. So let's have a look at some of the data, and you can see, temperature's going down a bit. I guess it's colder on the floor, and then we can talk about how some of the code works. Right, so here's my data. This is only a few days worth of data, I think, or is this the whole lot? I think it might be the whole lot. And you can see here that it's got its peaks and troughs. This is the raw data over here. And it's doing it every single minute. So I started it at 11:30 at night on the 5th. And then all the way down here, 5,070 minutes later. Whoops. There we go, it stops. At 17.3 degrees. And so I've just put a chart in so that you can see the data ranges. Now, and if I select the data here, somehow, you can then hover over and see the different values. So there it's 15.8. Up here, it's 19.9. So these peaks are when I'm home and I've put the heating on. So by this I think you could figure out when I'm home and when I'm not, which could lead to burglaries potentially. Anyway, so it gets down to quite a low level. This looks like the lowest point over here, 14 degrees, and that was at 9:25 in the evening. So I was in, but I didn't put the heating on until a bit later on. So this is where I've put the heating on when it starts to get warmer. And it keeps going up and up and up. So from this you can figure out how warm your house is, obviously, but also when the sun shines through, and you can see the heat building up in the house and how long it stays around for. Now, not entirely useful, but interesting all the same. So let's have a look at some of the code and how I've implemented it so it kicks out a CSV file. So here's the code. I'm using some of the standard examples, which is why you'll see lots of text in here, comments and stuff. But the idea is that it logs the temperature to an SD card, but also displays it on an LCD. And the logging part is done on the SD card and recorded as a CSV file. Now, it's a little bit complicated, so I'll make the code available for everyone to use. But I'm getting the value here, changing my float to a string down here, and I'm recording it to the SD card bit by bit. Now, the important part here is the write data to card function here, and it takes the time and it takes the data in and it writes it to my text file. Now, it writes the time, and on here I don't have an RTC connected, so I'm just incrementing the value every minute, so it's delaying by 59 seconds and an extra delay here of 1 second, and then so it's doing it roughly every minute. Now, it's not perfect, but I don't need it to be exact, so I'm not using an RTC. And then it's adding a comma here. We're using comma separated values so we can turn it directly into a CSV on the computer. And then it's using the float to string here so I can convert my value. And then it's adding the /n here to end the line. And then we close the file once that's written. Now, it's doing that forever. It keeps going and adds values over the top. It doesn't overwrite the data that's already in the file, so it just incrementally adds a bit of data after. And then once you disconnect, you can put it straight into the computer, change the TXT extension to CSV, and open it up in something like OpenOffice or Microsoft Excel and view your data and immediately chart it. Alright, well, thanks a lot for listening and watching. It's just a small project, not really that interesting, but it might help some of you who are looking to log data from your temperature sensor, and I'd love to hear what you get up to. Thanks.